Welcome back. I hope you're doing great. As a part of this video, we'll understand some of the low-level techniques for test case design. In the previous video, we understood some of the low-level techniques like equivalence partitioning, boundary value analysis. So we'll continue our journey of understanding low-level techniques to design the test cases. So one of the low-level technique is special value testing. What is special value testing? What happens is when a tester spends considerable amount of time in a project, he gets to know most of the components of an application or a system. And sometimes tester would be much better than the business analyst, much better than the developer. So in those cases, wherever the tester has stayed in a project for a more amount of time, our tester is a domain expert. In that case, we can have a special value testing done. So based on the tester's experience, he would be able to design the test cases. And this technique only applicable wherever the testers has good amount of knowledge of an application or a system. So special value testing is purely based on the past experience. Maybe when the tester has tested the product in the last build or in the last release, you would have uncovered some of the defects in a particular component, in a particular module. So the tester knows which module is vulnerable. So he will design the test cases based on that. Next one is error based or error guessing testing. So what happens here is when we have an application, there is a probability that errors may occur. Some of the errors occur because of the wrong inputs, because of the wrong navigation. So in the error based technique, what they do is they define the errors which are expected from an application as an action is performed. As a part of this technique, we'll guess the error. Oh, okay. In this case, the error may occur. Example is, let us say you have a window where you have to provide the first name, last name, and email. Then, assuming that the password edit box accepts 6 characters. If you only provide 4 characters, then it will prompt an error. Okay, there is an error here. So that way, we'll be able to guess an error and try to have a scenario around that in our test case repository. Cause and effect. So cause and effect is one of the technique in designing the test case. Here, what happens is for cause, there is an effect. For an effect to happen, there should be a cause. For example, now after furnishing all the documents from a customer, account will be opened in a bank. It's a cause and effect. One of the simple example. Here, what they do is they will come out with all the permutations and combinations of a situations that may arise while that application is being used. Then they convert the graph into decision table to obtain the test cases. Then what happens is a relationship is illustrated between an outcome and the factors that influence the outcome graphically. Based on that, test cases are derived. Now we have comparison testing. What exactly is a comparison testing? Whenever an application is supported on the multiple environments, multiple operating systems, in that case, we can go ahead with the comparison testing. So comparison testing technique will help us to check the performance of an application in different variants of an hardware and software configurations. Maybe how does the application work in 8 GB RAM? How does the application work in i3 processor? Like that, we'll have a testing done on a different hardware and software configurations. With the same data, testing is done on the different hardware or software configurations to see whether identical output is given by an application by using the same data. Sometimes we do run all the versions in parallel with real-time comparison results. That also will be done as a part of the comparison testing. So just to know what are the different variants of a comparison testing, at a high level, we will develop two separate independent versions of the software and test it in a different environments. And we will run all the versions in parallel in comparison with the results. Here we'll run the tests in isolation. Here we'll run the test concurrently. Awesome. We understood the important low-level techniques to design the test cases at a high level. Thank you.